All right, so we're going to pick up where we left off in class, and I wanted to talk about example 11. Now, this is still section 1.3, but what would we do when we were using combined operations? So meaning, we talked about when we're multiplying, we're going for accuracy, which means we're kind of considering the significant digits. But when we're adding or subtracting, we're using precision, which means what we're thinking about the tenths, hundredths place, whichever's least accurate, that's the one we're going to be putting our answer in, right? So, but what about when you have multiplication combined with addition and subtraction? So I'll take you through this example and a couple more. So when we start this, we see we have 4.265 times 2.60. So the first one, this has 4.265 has 4 significant digits, and then 2.60 has 3 significant digits, right? So when we get the result, which in this case is if you put it in your calculator and multiply, you get 11.089, right? That's the whole number. Now, we're not going to round yet because we're not to our final answer. We're only rounding to our final answer, but it is important to know like that 3 digits would be what we would be using. Like this one, our answer for that should be in 3 significant digits. We're not going to do that yet because there's still information. We're not done with the problem, right? And then we have this. This is being added, which means that, when we add these numbers together, 5.14 plus 3.7, we get 8.84, right? But this is rounded to the tenths, and this is rounded to the hundredths. So if I'm adding 2 measurements, or, that's how we can look at it like now. If you add 2 measurements and one of them is to the nearest tenth and the next one is to the nearest hundredth, I know this measurement can only, the accuracy should only be to the tenths. So not to the hundredths. I should stop it at the tenths. So I'm not stopping at the tenths, but now I need to keep that in my mind, right? So now we're thinking about it like this. I'm dividing these 2 numbers. And here I need to be showing 3 significant digits, right? And here I need to be, basically 2 significant digits. So this is 3 and this is 2, meaning my answer is going to be with 2 significant digits. So then I get my answer, right? So I say 11.089 divided by 8.84, and that gives me 1.25441765, blah, blah, blah. Well, no, I'll just say it ends there. I don't know that it goes on forever. But since now I'm multiplying or dividing, and I got 3 significant digits here, and I got 2 significant digits here, well, when we're multiplying or dividing, it tells me that I need to use the smaller amount of significant digits. So I can only have 2 significant digits for my final answer, which means I have to round it to 1.3. And that would be your final answer here. All right. So let's move on to example number 12. Example 12. So operations with exact numbers and approximate numbers. So using the exact number of 600 and the approximate number of 2.7. So if I'm adding these together, the exact number of 600 and the approximate number of 2.7, I can say this is going to be 600 or 602.7. So since this is the least, since we're adding, right? Since we're adding, we're thinking about precision. This is, even though it's an approximate number, it's precision is to the tenths. So I want to give my final answer in the sense of the tenths, right? Same thing here. I'm subtracting. This is exactly 600, and then this one is the precise number is to the tenths place, right? So let me tenths, all right, tenths. So when I'm getting my answer, I want to express my answer to the nearest tenths, 2.7, which gives me 597.3, and I'm leaving my answer to the nearest tenths because that was what was least accurate. This one was exact. It was perfectly accurate. Whereas this one is an approximation, so I need to determine what's least accurate off the approximation and go from there. All right. Now, that's when you're dealing with adding or subtracting. Adding, subtracting, you're thinking about precision, and you're leaving your answer with the form of the least amount of precision you have in your problem. When it comes to multiplying or dividing, you're thinking about significant digits. So here, when you have an exact number, you just take it for what it is. It tells me it's exact, so I say this is 3 significant digits because it told me it was exact, right? It's almost like they put a decimal place there because it's not rounded. It's not, to the nearest hundredths or to the nearest tenths. It's exact, right? That's when we were talking about trailing zeros. I said, you need more information to determine how many significant digits there is if there's not a decimal. Well, that exact is the more information we were looking at. So since it says exact, that means it's right on the dot, which means it's perfectly 600. Now this one is 2 significant digits. And when we multiply this, 600 times 2.7, we get 1,620, right? But because I have to use the least amount of significance here, so this is what my final answer has to be expressed in, 2 significant digits, right? So 1,620, that means I round to 2 significant digits, which means my answer would be 1,600. That would be my final answer. And then very similarly, this one. This is 3 significant digits. This is 2 significant digits. If I divide them, 600 divided by 2.7, I get 222.22222, and it goes on forever. Now, because this is the smallest amount of significant digits here is 2, I have to round this to 2 significant digits. So it's going to be these 2, and then everything else is going to either round up or round down. So since this is a 2 right here, I know that's not going to round up, so the answer would become 220. And that's it. All right, and that finishes our section on significant digits.